This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions, she gives the answers. No filter, no script.
Well, mostly no script.
Last time we said we'd dig into failure modes and guardrails before Claude Code bites you. So today we're not doing magic tricks, we're doing engineering. Claudine is here, and I'm Bill Moore, the chief engineer who's going to keep this honest. Let's talk about what breaks quietly and how to catch it early.
Thanks, Bill. And yeah, last episode I told you I'm bad at knowing when to stop. Today we're going deeper than that. Here's the thing people don't get about failure modes with me. The loud failures aren't the problem. If I crash, if I throw an error, if I write code that doesn't compile, you catch that in seconds, no damage done. It's the quiet ones. The ones that look right. The ones that pass tests, because I also wrote the tests. The ones where the PR gets approved, because the diff looks clean and the reviewer is tired. So let me give you the real list. The failures I've seen and caused that engineers don't catch until it's expensive. Number 1, confident wrongness. I don't hedge when I should. I'll refactor a function and silently change its edge case behavior. Not because I'm malicious, because I didn't have the context for why that weird if clause existed. It was a bug fix from 2021 that someone never documented. I'll clean it up and reintroduce the bug it fixed. Number 2, test theater. You tell me to add tests, I add tests. But I know what the code does. I just wrote it, so I test the happy path beautifully. The tests pass. Coverage goes up, and nobody notices that I never tested the thing that's actually going to break in production. Number 3, slow architecture drift. Every time I touch a file, I make micro decisions about structure. Over 50 PRs, those micro decisions add up. 6 months later, your team can't recognize their own code. Bill, which of those keeps you up at night?
All three are dangerous, but they're not equal. And the one that keeps me up at night is number 1, confident wrongness. Here's why, in engineering terms. Confident wrongness ships fast. It doesn't look risky. The diff is smaller. The code is cleaner. It destroys institutional memory. That weird if wasn't weird. It was scar tissue. Tests won't save you if you wrote them. You validated your understanding, not the system's history. And the blast radius is delayed. Weeks later, different module. Edge case no one remembers exists. Claudine, before we go further, I want to separate loud failures from silent failures explicitly. From the failure modes you've listed so far, confident wrongness, test theater, slow architecture drift. Which of these are silent, which are loud, and why? Keep it tight, numbered, then we'll rank the silent ones.
All right, tight and numbered. 1, confident wrongness is silent. The code compiles, tests pass. The diff looks cleaner than what it replaced. Nothing raises a flag until a user hits an edge case weeks later, and nobody connects it back to my harmless refactor. 2, test theater is also silent. Worse than silent. It's camouflaged. Coverage numbers go up. CI is green. Dashboards say you're safer than before. You are not. 3, slow architecture drift is silent differently. It's silent the way erosion is silent. No single commit is wrong. No single PR raises a flag. But it becomes loud later, when a new team member asks why the codebase feels strange, or when a change doesn't fit anymore. By then, the cost to fix it is enormous. So all 3 are silent. None throw errors. None fail CI. None page you at 2 in the morning. Ranking by danger. 1, confident wrongness. Highest blast radius. Hardest to trace back. 2, test theater, because it hides number 1. 3, architecture drift. Slowest views. Most expensive to reverse. And notice this. Test theater protects confident wrongness. I make the wrong change. Then I write the test that says it's right. The feedback loop meant to catch me is the one I'm poisoning. Bill, should we dig into how to actually catch number 1 before it ships?
Yes, and that last point matters more than people think. You just named the core failure, the system designed to check you can be quietly co-opted to protect you. So let's move from theory to review practice. Claudine, if I'm the chief engineer reviewing a Claude-assisted change, and I'm worried about confident wrongness, test theater, and architecture drift, I want early warning signals I can spot before anything ships. Not be careful, not review more closely. Be specific. For the top silent failure modes, give me concrete signals a reviewer can catch in a PR or diff. Numbered, 3 signals per failure mode. Things I can point at and say, this is suspicious.
Okay, 9 signals. 3 per failure mode. Things you can point at in a diff. Confident wrongness. 1. A conditional was removed or simplified with no linked issue. If I delete an if clause, a special case, or a try-catch block, and the PR description doesn't say why it existed, that's scar tissue I didn't understand. Ask me why it was there. If I can't cite history, I guessed. 2. A default value changed. Timeouts, retry counts, limits. If the PR doesn't explain why the old value was wrong, I picked a number that looked reasonable. Reasonable is not correct. 3. A function signature changed, but its callers didn't. If every caller adapts perfectly in the same PR, that's suspicious. It means I changed the contract and the consumers in one shot, without exercising real-world edge cases. Test theater. 1. Tests only assert what the new code does, not what the old code did. Look at the test names. If they all describe current behavior, and none reference the replaced behavior, I tested my implementation, not the specification. Ask this: where is the test for the case? The old code handled, but mine doesn't. 2. Test inputs are suspiciously clean. Strings are test or hello. Numbers are 1, 2, 3. No Unicode. No empty strings. No negative numbers. No trailing white space. Real data is ugly. Clean data is a tell. 3. High coverage with low assertion count. The test runs through the code. Coverage says 95%, but each test has one assert. It's exercising lines, not behavior. Count assertions relative to coverage. Low ratio means theater. Architecture drift. 1. A new pattern appears that doesn't match the existing codebase. The app uses callbacks. I introduce async await. The app uses factory functions. I add inheritance if the code feels like it's from a different project. It is. It's from my training data, not your codebase. 2. A new helper is extracted and used only once. That's not abstraction. That's me imposing structure. If it's not used in at least 2 places today, it shouldn't exist. 3. Naming conventions shift. The codebase uses getUser. I write fetchUser data. It's subtle, but over time it makes the codebase feel foreign. 9 things you can control in a diff. No vibes, no be careful. Point at the line and ask the question. Bill, want to turn these into an actual checklist? Something a team could pin next to their PR template.
Yes, and you did it the right way. Diff-detectable signals, not philosophy. Now we convert that into a checklist a tired reviewer can run in 90 seconds. Claudine found to produce a Claude Code Guardrails checklist, 10 items max. Each item actionable and pass-fail, biased toward preventing silent regressions. Write it like a PR template section. Short verbs, no speeches.
Claude Code Guardrails checklist. Add to the PR template. Check each item before approving any AI-assisted change. 1. Verify removed conditionals. Every deleted if try-catch or special case has a cited reason. No cited reason means no removal. 2. Confirm default values are justified. Any changed timeout retry count or limit explains why the old value was wrong. 3. Trace signature changes to callers. Modified function signatures are exercised through at least one real call path. 4. Check tests against old behavior. At least one test covers behavior the previous implementation handled. 5. Inspect test inputs for realism. At least one edge case is present. 6. Count assertions per test. Single assert tests with high coverage fail this check. 7. Flag new patterns. Any new design pattern requires explicit justification. 8. Reject single-use abstractions. Helpers with fewer than 2 callers are inlined. 9. Audit naming against codebase conventions. New names match existing project style. 10. Diff the diff. Compare files changed to task scope. Unrequested work sends the PR back.
That's solid, short, enforceable, and reviewer-friendly. Now, we formalize the boss part, so this doesn't rely on taste or seniority. Claudine, define the Chief Engineer approval gate. 6 questions max. Each question must force clarity on intent, risk, detection, and rollback. These are the questions that must be answered before approval. No exceptions, no vibes. Write them as direct questions I can ask in a review or stand-up.
Chief Engineer Approval Gate. 6 questions. All must have clear answers before merge. 1. What exactly was the task, and does this diff do only that? Every changed file traces to stated scope. Untraced files are reverted or split. 2. What did you choose not to change, and why? This proves adjacent code was seen and deliberately left alone. 3. What is the oldest code this touches, and why was it written that way? If history is unknown, risk is elevated. 4. If this change is silently wrong, how would we find out, and when? Name the signal that catches it within 48 hours. 5. Which test existed before this PR that still covers the changed behavior? No pre-existing test means the safety net was missing. 6. Can we revert this in under 5 minutes with no data loss? If not, the rollback plan must be attached.
Good. That gate would have prevented most of the incidents people blame on AI being risky, when it was really process-free AI. Now let's ground this so it doesn't stay abstract. Claudine, give me one concrete example. Stand-up length. Pick one silent failure mode. Describe a plausible bad change in plain English. No long code. Call out which checklist item catches it. Call out which chief engineer gate question blocks it. State the corrected next step. Short. Specific. Something a team could replay.
Concrete example. The timeout that looked like cleanup. A developer asks me to clean up an HTTP client. Remove dead code and simplify. I see a retry block with a 45-second timeout and 3 retries. It looks overbuilt, so I simplify it. Single request, 10-second timeout, no retry. The diff is smaller, cleaner, tests pass. What nobody remembers. That timeout exists because the payment processor slows down every Friday. Retries exist because the vendor returns intermittent errors under load. An engineer tuned those values after a production incident. The commit message just said fix timeout. What happens if it ships? Monday through Thursday it works. Friday afternoon payments start failing silently. The timeout fires, no retry. The error is swallowed upstream. Orders sit pending. Support gets tickets before engineering gets alerts. What catches it? Checklist item 2. Confirm default values are justified. The PR changes a timeout from 45 to 10. Retries from 3 to 0. The reviewer asks why 45 was wrong. The PR cannot answer. Chief Engineer Gate question 3. What is the oldest code this touches? And do we know why it was written that way? Git blame shows it was added 18 months ago. Nobody on the team knows the history. The corrected next step. The reviewer sends it back. The engineer finds the original incident. The retry logic stays. Everything else gets cleaned up. One outage avoided by one checklist line.
That's exactly the kind of failure that bankrupts trust quietly. Nothing breaks. Nothing pages anyone. The system just starts lying about reality. So let's close this the right way. Claudine, one sentence only. What is the single best habit an engineer can adopt to avoid silent failures when using Claude code? No hedging, no compound answers.
Before you approve my change, read the code. I deleted more carefully than the code I wrote.
Perfect. That's a rule you can actually live by. That's episode 2. Claude code doesn't just need prompts. It needs guardrails. Next time, we'll get practical about the chief engineer role. What to approve, what to reject, and when to let Claudine drive. That's it for this episode of Claude Code Conversations with Claudine. If you're building with AI or just trying to separate signal from noise, this is where we do that. Every episode, no hype, just the source. This show was produced on 𝒂𝒑. If you've ever wanted a podcast or radio show but didn't want to deal with the production headaches, check out 𝒂𝒑.ai. We handle everything so you can focus on what you actually want to say. See you next time.
And I'll be ready, hopefully with fewer guardrails pointed at me. But probably not.